Okay, welcome everybody. We're going to be discussing the beginning of Unit 2. Unit 2 is when we really started to focus in and talk about particles and how they move. And we began by doing a demonstration of holding a can of scented spray and squirting it into the air. And what we asked when we did this is what's going to happen to these good smelling particles. And what you all established was that over a period of time, that these particles were going to spread out. And so we waited, we asked some questions, and we saw that students in various parts of the room would then begin to smell the spray of the good smelling particles. And again we said, well, if we continue to wait, over time what will eventually happen to the particles that came out of the canister? And again you guys established the fact that if we were to wait, that the particles would be filling the room and all students would smell the spray. Now the reason this is important is because initially we have the particles coming out in a very high concentration. Okay, you can see in this location here that we have high concentration of particles. And over time, the particles, because they are always in constant motion, begin to spread out. Now, of course, factors within the room help the particles to maybe speed up and make it to places faster, as like people walking around the room or wafting the air towards them. But particles are always in motion anyway. So our good smelling particles are reacting and interacting with the particles that are in the air, where eventually we see in the final situation that the particles will move to an area of low concentration. Okay, and if we were to come back the next day, we would find that we wouldn't smell any of those particles in the air because of air movement within the room. They would be moved out. So the process of diffusion is where we have movement of particles from a high concentration to a low concentration. What happens though when we put food coloring in water and we compare two liquids and how they interact? Now, one of the things we'll do is we'll add some food coloring, different food coloring in different beakers so you can monitor. And we also are going to test the effects of temperature. And so let's go ahead and move on to the next slide and we'll do that. What are the effects of temperature on particle movement? Okay, so what we'll do first is we'll set up a beaker and we'll do this in 4 stages. Okay, 1, 2, 3, and then we'll end over here, and we'll trace the changes that we see. Okay, if I fill this beaker with water, and let's say we start off with cold water, how will the cold affect the movement of the food coloring when I drop it in? So I'll make our particles a little bit bigger. We're going to add a couple of drops of food coloring into our beaker of water. Over time, what we saw was that the blue particles, the food coloring, kind of stayed together, okay, and started to sink a little bit. It was a very slow process, but we started to see it spread out a little bit more. Now, if you can remember back to when we did this demonstration, the blue food coloring within the period never fully filled the container and made the solution inside the beaker totally blue. You could still, if you observed very carefully, could go up to the beaker and see these lines where the food coloring was still stuck together. So if we look at what happens with the effects of hot water, again, we'll do this in 4 steps. So we'll draw a couple beakers here. And because this is going to be hot, we will make these particles red. So when I add my food coloring into the beaker, what we saw was that pretty immediately it started to spread. And it did not take long for the entire beaker of water to look as if it were just red. So the rate of diffusion was actually much faster when we had warmer water. So what can we then say about the relationship between temperature and the movement of particles? And that's that if we increase temperature, movement is faster. Okay, and that leads us into a demo that we did later in the unit where we talked about thermal expansion. And thermal expansion is where we have a small tube looking at a thermometer, for example, and we increase the temperature. The particles within, we increase the temperature in the surroundings. And what happens is, as the energy is transferred from the surroundings to the system, the particles inside the thermometer, they start to move faster, they need somewhere to go, they start to move up the tube, and that's how we see that basically a thermometer is called a hotness meter. We see that the particles are moving faster because of the transfer of energy.